Okay, objective 184 is students will be able to solve quadratics using square roots. Okay, I'm going to move on. If you don't have that done, make sure you hit pause. Okay, first of all, let's just take a few simple things. The square root of 9. Okay, remember the square root is asking us, what a square root means is, what number times itself will give you that 9? Okay, and for this one, we're like, oh, the answer is 3. 3 times 3 will give us 9. Okay, but there's also another answer. Another answer to this is actually -3. And this is probably something that your middle school teachers probably didn't teach you or didn't get into detail on. Okay? And the reason why the answer is also -3 is because if you take -3 times -3, what's that going to get you? Well, that's going to get you a +9. Okay? So the actual answer to the square root of 9, okay, the actual answer is plus or minus 3. Okay, and all this is saying is that the answer is a positive or a -3. Okay, that's really important to today's lesson that you understand that. Okay, all right, the next notes asks you, when we are trying to solve a quadratic equation, what are we really trying to find out? I want you to stop and think about that a second. When we are trying to solve, what are we trying to find out? Okay. The answer to that is we are trying to find the points on the x-axis where the graph crosses, and let's just say it again, where the graph crosses the x-axis. Okay. So again, when we're solving, if we look at any quadratic, what we're trying to find are these points, okay, where it crosses. Okay, and if we had a quadratic that, looked like this, what we are trying to find, and your arrows should be a little more accurate than mine, okay, are the points on this x-axis where they cross. Okay. Now, one other important thing is we know that when we are finding the roots or zeros, okay, those mean the same thing. We know that think about the y-axis. Any point that is on the x-axis, we know that the y is 0. Because again, if I look at this point right here, right? Let's just say this point is right here at 3. Okay, this ordered pair is going to be 3, 0. Okay, because I'm going to go right 3, and then I don't go up and I don't go down. So any point on this x-axis is always going to have a y value, okay, a y of 0, and that should be reviewed. And again, this is the reason why, if you actually think about the ordered pair, okay, it's always going to have a y value of 0. Okay. So let's go on to example 1. Okay, it asks you x squared is equal to 16. Okay, now when you thought about equations before, and we've gone over this, if it was like, 2x is equal to 10, you would ask yourself, what's being done to x? You would say, oh, it's being multiplied by 2. And then we would ask, how do we undo multiplication by 2? Okay, well, we're going to ask ourselves the same thing here. We have x, and we ask ourselves x is being squared, right? So we're going to ask ourselves, and you need to get this down in your notes right underneath this. Okay, we're going to ask ourselves, how do we undo a number being squared? oops, how do we undo number being squared? Let me get that spelled correctly. Okay, and the answer to that is we take square root. Okay, again, you're getting this right underneath example 1. Okay. So then, if you need to, you can rewrite it in your notes, the original problem. So x squared is equal to 16. All this is asking is what number times itself will give me 16. And the mathematical way of showing this work is to take the square root of both sides. Because what happens when you take the square root of a number? The squared cancels out because they're inverse operations. Okay? And then the answer would be x is equal to, well, we have two answers, right? 4 and negative 4. Both of those, when you multiply them by itself, will give you the 16. So the way that we show this answer is simply x is equal to, and then the plus or minus 4. Okay, that's your answer to example 1. Okay, 2. Again, if you have questions as we are going through these, make sure that you write a big question mark in your notes so that you can ask it in class right away. Okay, this is asking us what number times itself will give us negative 4. Okay, and if you do this, go ahead and let's show the work for this. Show the math. So we would say, oh, let's take the square root of both sides. That cancels. Now, on your calculator, I want you guys actually doing the square root of negative 4. If you don't have your calculator on you, hit pause and go get it. Okay, so do the square root of negative 4. Okay, and it'll say something about an error or no real answer, depending on the type of calculator that you have. And the reason why is because no number times itself can give you a negative number. Oops. Can give you a negative number. Okay, so the answer to this one is actually no solutions. And I like to put the word solutions plural because you could leave it singular, you could write no solution. But remember, when we're solving quadratics, typically, okay, not always, but typically, we're looking for 2 points, okay, where it crosses. So that's why I say no solutions, because there aren't the 2 points where the parabola crosses the x-axis. Now, remember, it's not always true. You could have a parabola like this, you know, that only has one solution, or you could have a parabola like this that has no solutions. And that's actually what this one is. It's something where the parabola does not cross the x-axis at all. And I want you guys on your calculator, let's check it. So, and I want you to add this as a key point underneath example 2. Okay, always double check no solutions by graphing on calc. If you ever think that the answer is no solutions, double check it by graphing on the calculator. Okay. Now to do that, we need this quadratic in standard form. So we did have x squared was equal to negative 4. Okay. So we need to get this in standard form, which remember is y equals the ax squared. So we basically need to get this negative 4 on the same side as the x squared. So I need to add 4, add 4. So my quadratic that I can graph now is y equals the x squared plus 4. Okay. Now on your graphing calculator, go ahead and plug that in. And if you don't have a graphing calculator, you should be thinking, well, what do I know about the y-intercept? And what do I know about where or whether this opens upward or downward? Okay, so I'm going to take a second. I'm going to graph it on my graphing calculator. And when I do that, I see a graph. I'm going to erase this one here. Here's what my graph looks like, and even without a graphing calculator, you should be able to figure this out. The y-intercept is at positive 4, right? And then this opens upward because it's a positive. Okay, so your quadratic looks something like this. Clearly, this quadratic never crosses this y-axis here. So we know our answer of no solutions is correct on this one. All right, let's go on to example 3. Actually, I want you guys at the bottom of that page again, so underneath example 2, hopefully you have some room on your notes. I want you guys to write a key point for this objective. Okay, and the key point is this, is that using square roots to solve quadratics. Okay, works when b is equal to 0. Okay, so we are left with, and we should add, we're left with or need to convert to something that is x squared is equal to a positive number. Okay. So again, the b, so essentially, you know how our standard form equation is ax squared plus bx plus c. Okay. This b, again, using the roots, works when this b is 0, meaning we don't have a term. You notice in the last two examples, we don't have a term or a coefficient in front of x. It's just something squared and then our constant. Okay, that's when we can use these roots to solve quadratics. It's really important that you understand when you can use them. Okay, so now let's go on to example 3. Okay, example 3 looks like this, 5x, I'm going to actually rewrite it down here. You guys already have it on your paper. So it looks like 5x squared minus 125 is equal to 0. Okay. Now, this is really important, right? If we look at this, okay, we only have A and C. B is equal to 0. Okay. So, let's just say, so try using roots. Actually, we should not just roots. Try using square root. And in order to use this square root, we need it to be in the form x squared is equal to a number. Okay. So how do we get this to be x squared equals a number? Well, we need to move this 125 to the other side. To move a negative 125 to the other side, I need to add 125. Whatever I do to one side, I have to do to the other. That leaves me with 5x squared is equal to 125. Now you just need to solve for x. You ask yourself what's being done to x. Okay, and let's just do the do and the undo box for this real quick. What's being done to x is we're multiplying by 5. So I clearly need to divide by 5. X is also being squared. Okay, how do you undo x being squared? You take the square root. Okay, now we use reverse GMDAS and we need to do this division first. So I'm going to divide by 5. Divide by 5. X is equal to, or x squared is equal to, that would be 5. Okay. Now we're not done yet. We need to solve for x. X is being squared, so we take the square root of each side. What happens when you take the square root of a number being squared? They cancel. So I'm left with oh, I'm sorry, I made a mistake. You guys aren't in class to yell at me, which you probably are yelling at your computer. This is 25, not 5. Okay, so I'm left with x is equal to, now don't forget, your answer is not just 5. Okay, your answer is 5 and negative 5. So again, we show that as plus or minus 5. Okay, and that would be your answer. Okay. Now, again, if you go back and you graph this equation on your graphing calculator, if you go to the y equals, plug in 5x squared minus 125, and then you can use your table function and find out the two places where y is equal to 0. Okay, and you're going to see in your table that your two answers are going to be where y equals 0, it's going to show negative 5 for x and also positive 5 for x. Okay, that's how you can check it to make sure you know you got it correct. Okay. All right, let's do example 4. Okay, example 4 is 4x squared minus 25 is equal to 0. And right away it has equal to in it, so we know that we need to solve this. We know that we need to figure out the roots or the zeros. Okay, and again, on this one, it only has the a and c. b is equal to 0, right? There's no term that just says something x. Okay, so this is where, again, we try to get it in the form x squared is equal to a number. Okay, so let's go ahead and do that. So I need to add 25 to both sides. I'm left with 4x squared is equal to 25. Okay, and then I need to finish solving for x, so I need to divide by 4. Divide by 4. X squared is equal to 25 over 4. And that can't be reduced. So now I need to take the square root of both sides. That cancels. And it leaves me with, let's see, it leaves me with, okay. So I think, let's show our work this way. It leaves me with x is equal to plus or minus. Okay, remember, whatever that's going to be, it's going to be plus or minus. Now, another way that we can show this, because both the 4 and the 25 are underneath the radical, I can rewrite this to be the square root of 25 over the square root of 4. Again, I'm not changing it at all. Both of these were already underneath this radical symbol, so I'm just writing it differently. Okay. Now, do you know the square root of 25? And the answer is, yeah, so I'm going to write plus or minus again. Square root of 25 is 5. Do you know the square root of 4? Yeah, the square root of 4 is 2. Okay. So your final answer for this one that you end up with is x is equal to plus or minus 5 over 2. Okay, or you could show that as 2.5. So you could show it as this, x is equal to plus or minus 2.5. Okay, both of those answers are correct. Okay, let's go on to example 5. Okay, example 5 says 0 is equal to x squared minus 10. Okay. All right. On this one, the same thing. You're only given an a and a c, right? The a is the 1 in front of the x squared, and your c is your constant 10. b is clearly equal to 0 because there's no just regular x term. Okay. Now, with this, we want to keep, make this note, we want to keep the x squared positive. Okay. Right now it's already positive, so we don't want to move that to the other side because then that would make it negative. Okay. But we do have to get this x squared by itself. So how do we do that? We need to move this negative 10 to the other side by adding 10 to both sides. So that leaves me with 10 is equal to x squared. Okay. Now, if you want, you can change the order of this and rewrite it so that x squared is on the left. Okay, again, that doesn't change the value of it at all. Okay, and then we need to take the square root of both sides. That will cancel. So x is equal to plus or minus the square root of 10. Okay. Now, you could actually leave this as an answer, and the reason why is because we don't know, the square root of 10 is not a perfect square root. Okay. But if you're actually really wanting to find out the exact places where this parabola crosses that x-axis, you can take the square root of 10 and then estimate it. So we would have x is equal to plus or minus, and if you do the square root of 10, it's about 3.16, and that's the rounded value. Okay. Either one of these answers, and again, depends on the test, depends on how exact you want to get. Okay, either one of those answers will work. Again, we typically leave the radical because it's more exact, right? This is rounded. Okay, this 3.16 is rounded. We try to avoid rounding whenever possible. Okay, example 6. Okay. Just so you know, this is, if you get stuck or you're still confused, this is lesson 9.6 in your book. Okay, this is lesson 9.6 in your book. So the original problem gives me a plus 4 squared is equal to 49. Okay. Now, we could go about this and do something a really long way. Okay, you should notice here that this is, and I should ask you the name, what's being done with it? What is this side right here called? Well, it's the square of a sum. A lot of you are still struggling with the names on that. It's the square of a sum. Okay, you could do this the long way. Okay, so the long way, and I'm just going to show you now. I want you to get this in your notes. Okay, now that we know it's the square of a sum, we know kind of the smart cut formula is a squared plus 2ab plus b squared. Okay, so that would be a is 1, so you would have 1 squared. So you would end up with, this would stay a squared plus 2. Again, a was 1, b is 4, plus b squared, okay, 4, b is 4. So you end up with a squared plus 8a, because that was a 1a in there, and then plus 16, and then you would set that equal to 49, because you can't forget about that. And then if you wanted to, you would have to, again, set this equal to 0, set this equal to, so we need to move that 49 to the left, so you end up with a squared plus 8a minus 33 is equal to 0. And then you could try using the AC method. Later you'll learn you could try using the quadratic formula. Okay, but there's a much easier way that we can try to solve this. Okay, so I'm going to rewrite it. You guys shouldn't have this box around here, so you shouldn't need to rewrite it. So you have a plus 4 being squared, is equal to 49. Okay. Well, how do you undo this entire thing in parentheses being squared? You can take the square root of this entire thing. If you take the square root of one side, you also have to take the square root of the other. Okay. What happens with the square root and the square? They cancel. That leaves you with a plus 4 is equal to. Remember, again, you cannot forget this. Okay, you're so used to just saying, oh, the square root of 49 is 7. No, the square root of 49 is a positive or a negative 7. Okay, really important that you don't forget to do that. So then you would still solve for a, so minus 4, minus 4. So you end up with, that cancels, a is equal to, you have negative 4 plus 7. Okay, and you have a equals negative 4 minus 7. Okay, so a in this case is going to equal, this would give me a positive 3, this would give me negative 11. So your two answers on this one are 3 and negative 11. Okay, there are 3 and negative 11. Those are the two places, okay, on the x-axis where this quadratic, if we graphed it, is going to cross the x-axis. Okay, let's do example 7. Okay, example 7, you guys have in your notes already, is y squared minus 4y plus 4 is equal to 25. Okay. Now, if you look at this one, you should be thinking, oh, this one has a b. Okay, this one has a b, so you can't just use, you shouldn't just be thinking, oh, use square roots on this one. Okay. Typically, we would use this, we would solve this, and you can just watch right now, you don't have to get this down. We would solve this saying, okay, well, I need to set this equal to 0, so then I'd have y squared minus 4y is equal to negative 21. Oh, I'm sorry, not equal to, but let me just erase that. And then minus 21 is equal to 0. Okay, and then you would be asking yourself, okay, well, what? So we could factor it using the AC method. We know the signs are going to be different. So what multiplies to give me negative 21 and adds up to be negative 4, and the signs have to be different. And the answer to this one is going to be negative 7 and 3. Okay, so because this is a positive 1 as a coefficient here, we would simply have x minus 7 and x plus 3. Okay, and then you would set both of those equal to 0, right? Because we're solving, it has the equal to sign. So you would end up with this case with an x is equal to 7 and an x is equal to negative 3. Those are your two answers. Okay, but I'm going to show you a different way of solving it. And again, knowing these multiple ways really helps out on the trickier types of problems that you may see on the ACT. So I'm going to rewrite example 7, and this is how I want you guys solving it with me. So y squared minus 4y plus 4 is equal to 25. Okay. We should see on this, if we just look at this right here and kind of ignore that 25 for now, okay, we should see that this is the same. This tells us that the signs are going to be the same, right? So in our head, we can ask ourselves, okay, what multiplies to give us a positive 4 and adds up to give us a negative 4? Okay, so let's get this down. Let's see, so what multiplies to give us negative 4, I'm sorry, positive 4 with a sum of negative 4. And the answer to this would be negative 2 and negative 2. Okay, so now I could actually rewrite this thing that I have in parentheses. I could rewrite it as this. This is y minus 2. Again, because my two factors here, right? If I just factor this part in parentheses, I'm going to end up with y minus 2 and y minus 2. Well, what's another way of writing y minus 2 times y minus 2? You can write it as y minus 2 squared. And that's going to equal 25. Okay. Now we can solve this using the root. Okay, using roots. So we can take the square root to cancel, take the square root. I'm left with y minus 2 is equal to, I know the square root of 25, so I can go and simplify. It's plus or minus 5. Okay, and now I got to move this negative 2 to the other side by adding 2. So I'm left with y equals a positive 5 plus 2, and I'm also left with y equals a negative 5 plus 2. And you notice this will give you 7, this will give you negative 3. You notice these are the exact same values as before. Okay, when we used what method we knew before of getting everything on the same side, setting it equal to 0, and then factoring. Okay. Now, that one that I showed you, the way I factored it, actually worked out using the AC method. Some of them will not work out so neatly. Okay, so it's good to learn some different methods. Okay. Okay, example 8 is a minus 3 squared is equal to 5. Okay? So again, first thing I should be thinking right away, okay, I need to solve for a. I could do the box method, or no, this is at the square of a difference and write out the formula, but I can also just try taking the square root to cancel and see if it works out. Okay, so I'm left with a minus 3 is equal to plus or minus the square root of 5. Okay, now I don't know the square root of 5. It's not a perfect square. Okay, so let's put a note here, not perfect square. Okay, comma, so leave as radical. Okay, most of the time on tests and on the ACT, if it's not a perfect square, you're going to leave it as a radical. Okay, so when we do that, we'll end up with a minus 3. I'm just rewriting it. You guys should have room, hopefully, in your notes. Okay, and then I'm going to add 3 to both sides. Okay, and the way that you show this answer is you show it as a is equal to the positive 3 here, and then it's plus or minus the square root of 5. That's how you will typically leave your answer. Okay. Now, if we wanted to have a little bit better idea and try to be exact, we could actually do the square root of 5 on our calculator, and you would end up with 3 plus or minus the square root of 5 is about 2.24, I think. Okay, and then you could actually do 3 plus 2.24, okay, and you could do 3 minus 2.24, and you could get, you know, your more exact values, or at least you could picture it on a graph where it crosses, you know, this square root of 5. I can't really picture where that's going to cross the x-axis. Okay, last example that we're going to do, example 9, 1/5, and then you have z plus 3 squared is equal to 7. Now, before we take the square root, and we're solving for z, right? Before we take the square root, we need to undo this whole thing. This left side is being multiplied by 1/5, okay? Before we do the square root, we should undo that multiplication first. So how do you undo multiplication of this thing in parentheses? It's being multiplied by 1/5, right? So we need to divide by 1/5. Okay, that's going to cancel. That leaves me with z plus 3 squared is equal to. Now, how do we multiply by a fraction without a calculator? You multiply by the reciprocal. Again, that's key that you have that memorized. How do you divide, or I think I said multiply. How do you divide a fraction without a calculator? You simply multiply by the reciprocal. So that's going to leave me with z plus 3 squared is equal to 35. And then we can do the square root. That will cancel. So I have z plus 3 is equal to the square root plus or minus the square root of 35. Okay, and then I would subtract 3 from both sides. Subtract 3. So my answer on this is going to be z is equal to, show this negative 3, so negative 3, and then plus or minus the square root of 35. Again, I leave it as the square root of 35 because 35 is not a perfect square. So it's going to be an irrational number, a decimal that doesn't repeat and goes on forever. So therefore, just leave it in radical form. Okay. All right, examples 10 and 11. I want you guys to give those a try for homework. And I want you to do them on a different piece of paper. That way, when we go and do them in class, you have the correct work in your notes. So as part of this video on homework, you need to do examples 10 and 11 on a different piece of paper. And I'm fine with you doing them on your spiral and grit piece of paper on the back if you want.